Hi, everyone. Welcome to SingleStore's webinar, how to launch LLM ChatGPT application in just 3 simple steps. I'm Shweta Agarwal from SingleStore. I look after the Asia Pacific marketing for SingleStore, and I'm very happy to see all of you guys here joining us today. We have a whole bunch of our panelists, experts, who are going to tell you how to build the application today, and I'm going to introduce them to you. We have Akmal Chaudri with us. Akmal is our Chief Developer Evangelist. Akmal helps build global developer communities and raises technology awareness through presentations and technical writing. He has over 25 years of experience in IT. He's previously held roles as a developer, as a consultant, so he's worn multiple hats, and as an evangelist. He's also a technical writer. So if you've got time, you can look up to his Medium blogs. It's called Very Fat Boy. It's very, very technical. I personally enjoy it a lot. Then you can, he's a technical trainer with several blue chip companies and big data startups. He has regularly presented at many international conferences and served on the program committees for major conferences and workshops. So he has published widely and co-edited 10 books. He holds a BSc First Class Honors in Computing and Information Systems, MSc in Business Systems Analysis and Design, and a PhD in Computer Science. We are very honored to have you, Akmal, with us. He's also a member of the British Computer Society and a chartered IT professional. Along with him, we all have Nidhi and Ankur with us. So Ankur is our pre-sales head for SingleStore for the Asia Pacific, and Nidhi is a support sales engineer for the Asia Pacific as well. So they both are going to live answering your questions. So you feel free and encouraged to ask questions through the Q&A section. Throughout this, there are 3 basic hygienes that I would love for you guys to follow. Number 1 is that follow through the steps. Anytime you stumble, please address this through chats and Q&A, and we are there to help you. Number 2, log into singlestore.com, create your cloud trial account. This will save you a lot of time doing that at the time of doing and following the instructions. We have good amount of time, but I would encourage all of you to go to singlestore.com/cloud trial and create your logins now. It will just hardly take 10 seconds. The third important thing, we have a surprise for you. So today we are going to choose a winner who's going to receive an AirPod. So I encourage you to follow the instructions and spin up your clusters. And I hope you're able to build the LLM app through these simple steps. And one of you is going to receive an AirPod. So over to you, Akmal.
Great. Well, thank you very much, Shweta. And so thank you very much for all of you for joining. So I'm actually in London, and so my time here is before lunchtime. It's just gone 11:30. I think for many of you, it's kind of early to late evening. So sorry about that. So, but we'll give you some great experience, hopefully, and give you a chance to learn some interesting stuff today. And so it's not just me. Okay, so this is a team effort. So as you can see, there's 4 of us available here. And so, although I'll be doing a lot of the presentation, my colleagues will be supporting and helping answer the questions as well. Okay, so thank you very much for them as well for this. So let's me share my screen and let's take a look in terms of which browsers I want to have a look at. Let's take a look here. I think this one should be okay, and I need to find the appropriate window. Too many windows open. This one. There we go. I think that's the one I want. Just minimize these other ones, and let's get into presentation mode. Okay, and I just asked my colleagues Shweta and Ankur and Nidhi if you see me saying something and maybe you're not seeing the screen exactly as I might intend, because I may have multiple screens open, let me know, okay, so that I can fix that straight away. But hopefully everyone can see the title there, and this is the presentation. So we've got approximately 2 hours or so, and the reason for having this kind of extended webinar, because normally we keep it to an hour, but if you want a hands-on session, okay, because as Shweta was saying, the time is needed, you know, you need to create some accounts, takes time to spin up some resources as well, and that kind of eats into it. So an hour is not enough, okay? So we want to give you a good experience, give you the opportunity to try something out for yourselves as well, and therefore more time is really needed for that, a bit more relaxed in terms of environment and pace as well. Okay, there we go. And so please, if you do have questions, use the Q&A. Okay, my colleagues will be there to assist. I will do my best to answer the questions as well as we move along. So this is a picture of me when I used to have hair. So as you can see, I kind of, you know, lost the hair over time. Probably most of the reason for that is publications, right? So books take a long time to publish. In the old days, it used to take like 2 years. You know, you have an idea for a book, takes you 2 years before you actually see it in your hands physically. And nowadays, that is just not possible, simply because of the pace of technology, how fast things move. I mean, just look at the last 6 to 8 months in terms of ChatGPT and OpenAI, phenomenal interest in this technology and really incredible uptake. And of course, at SingleStore, I mean, we are very well positioned in this regard as well, because some of the things that we'll be using today are technologies that the product has had for some time. Okay, so it's not something we just added simply because that happens to be popular today, but these are kind of capabilities that the product has had since 2017. Okay, and we'll get onto more of that shortly. Okay, so as far as the agenda goes for the presentation, well, it's very, very straightforward, and I'm going to keep it reasonably short. It's going to be fairly introductory because, again, we want to give you an opportunity to get your hands on the technology and be able to build some, you know, use some code and to build something. And that's really what we want to focus on in terms of the hands-on labs. All right. All right, great. So this, as Shweta mentioned, is the AirPods raffle. Okay. And so if you have a look at that, so either take the bit.ly link there, or you can scan the QR code. And so as we can see here on the left-hand side, hopefully this is all working well. Let's take a look at this. All right. So anyone who answers all the questions at the end of the event day will be entered for a chance to win new branded AirPods Pro. Sadly, I think the 4 of us from SingleStore are not eligible to enter this. Okay, so we're out of the running. That leaves more chances for you. So the other thing is that as you take that bit.ly link, okay, let me just clear this. So it's bit.ly/AWS-ChatGPT LLM, or one word there, as you can see, -raffle. And if you use that and create an account, literally, it will take you like 1 to 2 minutes, seriously. And just enter that in. You'll just be asked for some, you know, login details. So you can use your personal email address if you wish, although corporate email address is always better, okay? Because it gives us an opportunity to verify and confirm and to follow up with you later on. But it's your choice, okay? I mean, that's entirely up to you. And just create a password as well. And actually, why don't we do that? Let me just stop there a moment, and we can take the opportunity to do this. Okay, so let's just do this. Let me just select this. Okay, and just make sure that you are seeing my desktop. That's correct. You're still seeing my desktop. So I'll open this in Safari, okay? Because the thing is, the current browser I have already has me logged in. So I'm just using that bit.ly link. Okay, there we go. And it will take you to this page here. Try SingleStore Cloud for free. Okay, and so as you can see, you get $600 worth of usage. And you can, if you wish, use sign up with Google or Microsoft, or if you prefer, I think you can use an email address there. That's fine too. So like I said, it just asks you for a little bit of information: first name, last name, email address, and it will just verify that email address. And once you've created the account, please just log in. Okay, so we'll look at that a little bit later on. So it's helpful if you do this now, so that we don't have to spend time later doing this, and that will just speed up the process in terms of your experience as well. Okay, so there we go. So I'll shut this down now, okay, and minimize this, and we'll get back to our slides. There we go. Hopefully, again, you can see that. There we go. All right, so once more, I'll just leave that there for a moment for you, okay? So it's just bit.ly/AWS-ChatGPT LLM, all one word, -raffle, or use the QR code there, and you'll be entered into this awesome draw. Great. Okay, so I'll show this again later, okay? So don't worry if you didn't get that, but it should be fairly straightforward, all right? So we'll move on, okay? Because let's get these slides out the way so we can get onto some hands-on. There we go. All right, so a little bit of an introduction then. And so SingleStore, as a company, it's been around for over 10 years now. And originally, the company and the product used to be called MemSQL. MEM-SQL. And the reason for that was it was very much a transactional in-memory database system. And over time, there was a kind of a realization that, okay, you know, OLTP, which many of you may be working in, that's great for sort of one class of problem, if you like, for transaction processing. But equally, we see a lot of usage and interest in OLAP, online analytical processing. So there is a requirement to be able to do analytics and do analytics very fast. So operations like sum, min, max, average, count, these kind of things. And again, to be able to deal with vast quantities of data. So a couple of years ago, the company decided to offer this kind of columnar storage as well, in addition to the in-memory capability. And then subsequently, it became universal storage. So there is a single table type now that can be used, and it gives you a lot of robust capabilities in terms of storage, because now we are not just in memory, okay, but with this kind of vast columnar data that's stored, you know, it's stored to disk. And because it's cloud-based, again, there's a choice in terms of how that storage is undertaken, you know, using solid-state drives and various sort of storage levels that are provided. That is something that we can go in beyond this particular webinar. So that's one aspect. The other aspect is that if you think about it, what has happened over the last 10 years or so? Well, we have seen the development of these so-called distributed SQL databases. So if you go back in time, and maybe you are kind of familiar with things like Hadoop, for example, which emerged a bit over 10 years ago, distributed processing, the ability to take off-the-shelf hardware, create clusters of machines, and be able to effectively bring the processing to the data, rather than having to move the data around to the processing. So it kind of flipped itself on its head. And therefore, this is a very useful concept. And around that time, we saw the emergence of some particular database systems, NoSQL in particular, which utilize some of these capabilities as well. But you know, in the world of SQL, which is still very dominant, and the vast majority of database systems today are still relational database systems. And the thing is that they kind of fall into several camps. So you have the kind of the old world, if you like, you know, the vendors that have been around for some time. You can probably guess whom I'm thinking of. And those guys, they have monolithic products. So if you want to improve data processing, you want to improve performance, effectively, you have to buy a bigger box, okay? More sort of hardware, if you like. On the other hand, with this emergence of distributed SQL databases, now you can take advantage of some of these distribution capabilities, and you can use clusters of machines as well. And you effectively have what are the benefits, what the NoSQL crowd kind of developed, but at the same time, you keep your investment and your skills and all the tools that you've used in SQL, and you can still utilize those. Okay, so this is the real benefit that you have. And SingleStore DB, company changed its name, obviously, to reflect the fact that we do single store in the sense that you have a single table type now that can deal with multiple different data types. Okay, so we see that over here. Okay, so this is a kind of a nice high-level view. I like to think of this as the kind of 30,000-foot view of what the product is. So at its core in the middle here, you can see that we have this product with this universal storage that can handle both, pardon me, OLTP and OLAP, and give you awesome performance on that. We can work with a variety of modern technologies such as Spark and Kafka and so on, and even Hadoop, all of these different technologies there you can see on the left-hand side. We can be provisioned in the cloud. Okay, you can see some of these. The three major cloud providers in the Western world, AWS, Google Cloud, Microsoft Azure. You can run on-prem as well if you wish. A Docker version is available too. I sometimes install SingleStore inside a virtual machine that I have on my particular Mac, for example. I mean, I can install a small cluster, very small cluster, 2 nodes, okay, a master node and a leaf node, but that's sometimes very useful to do and to be able to demonstrate. And then you can see on the right-hand side, well, we are obviously a relational database still, okay? That is very much the core of what we do. But additionally, we offer a whole range of additional sort of features and capabilities. So we can handle geospatial data. We can do full text search, okay? And so the full text search is based on the Lucene engine, which you may be familiar with. We can do key value, JSON, okay? And we have an awesome offering that we released this year, which is SingleStore Chi, which is, if you are a MongoDB user, it gives you the opportunity to do awesome fast analytics using Chi as something that can augment your existing Mongo environment, or if you want to replace that entirely with SingleStore, you can do that as well. No code changes, okay? Your apps can move across. And just a couple of days ago, I actually did a presentation, a webinar that talked about benchmarks and performance in Chi with one of my colleagues from the United States, Vijay. We also have a couple of other things as well. I'll get rid of those arrows because it's getting a little bit crowded there, as you can see, but we also have support for time series. And the last but not least, this concept of vectors, okay? Something that's become very popular over the last sort of 6 to 8 months, in particular because of the growth and interest in OpenAI, ChatGPT, and a lot of these other offerings, both open source and commercial, in the large language model or LLM space. By the way, the term LLM is kind of interesting because it's overloaded in the sense that this is something that if you are a lawyer or you've done undergraduate studies and you've graduated in law, you go on to do a master's. Well, the master's is called LLM. So recently, I've been posting on LinkedIn and other places, LLM. I am kind of inferring it stands for large language model, but I get a lot of people viewing my LinkedIn profile and I look at them and they are actually lawyers and doing master's degrees in law. So, it's one of these things that is a kind of a happy coincidence, I guess. Okay. All right, then. Now, let's move on and talk a little bit more about the machine learning aspects of this then. So this is not an exhaustive list. It's just to show you some representative examples of the different ways that you could do machine learning and AI and so on with SingleStore. So in the past, for example, I've used Apache Spark, okay, mlib. And SingleStore obviously has a number of different APIs and language bindings. So if you are familiar with R, for example, or Python in particular, then you can utilize many of those libraries and you can connect to SingleStore. You can do machine learning that way. One of the things that SingleStore provides is kind of very, I wouldn't say unique, but it is very differentiated from a lot of the relational crowd. I mean, there are one or two other vendors that provide this capability, is this concept of WebAssembly. So WebAssembly is very useful in the sense that now you can take some existing code that you have, say it's in C++ or Rust, for example. I think Python and other dynamic languages support for that is coming, but you can now extend the capabilities of the core database engine. And this WebAssembly runs in its own space, okay? It isn't something that if there's some data corruption or something, it won't affect your database system. It runs in a protected kind of environment, but allows you to extend the engine in very unique and interesting ways. And one of the examples I've shown of the last 2 years or so that I've been with SingleStore is sentiment analysis, for example, where I've used something called VADA, Valence-Aware Dictionary and Sentiment Reasoner. And this is using some Rust code and some libraries, packaging that up, storing that in SingleStore as a procedure or a function. And then the system then uses that because it thinks treats it just like any other UDF. And then I can apply that to data at scale. And I can really put a lot of machine learning code inside the database system. Our focus today, though, is very much on these two aspects, though, the last two here. Okay, so we are going to look at these vector functions. And in particular, we are going to do it in the context of OpenAI. And so vector functions have been in the product since 2017. We were actually asked originally by one of our customers, happens to be in the financial domain, and that's where it came from. So lots of vendors are adding these vector capabilities today simply because of the interest in large language models and things like ChatGPT and GPT in general and LLMs and so on. But keep in mind that SingleStore has had this capability for quite a long time. It's mature, it's battle tested, okay? Customers are using this in production environments already, not necessarily for kind of OpenAI type stuff, for example, or LLMs, but for other requirements that they have, things like image matching, for example. But the thing is, these functions are built into the system. They are not simply a layer or an add-on. That is something that we've had in the product for some time, and that is, I think, something that is going to be very useful for a lot of the requirements that we have in terms of working with large language models going forward. And of course, the company has a roadmap as well, and we are investing considerable engineering resources, improving those capabilities. So expect to see some announcements, hopefully later this year. And these things, as you know, always depend upon other requirements as well. But there's going to be some very interesting announcements, I think, in the very near future. Okay, so let's say a little bit about vector databases. Okay, so a few more slides to show you. And so what do we want to use a vector database for? Well, typically then it's for this type of sort of searching. It's nearest neighbor type of searching, okay? And we'll look at that momentarily, okay, once we start the hands-on labs. But typically then for, if we look at sort of text, or we want to look at things like images or, even sound, for example, we need some representation of that to store it in the database system. Now, for us as human beings, if we look at a picture, for example, of a cat and we see another picture of a cat, well, we kind of identify, we recognize the fact that there's a cat appearing in both of these pictures. But the thing is, how do we tell software? Well, how do we tell an algorithm that there is an animal in this picture and it happens to be a cat? There is a kind of a mathematical representation of that. This is why we need these vectors, kind of numerical representations, numbers that will give us a representation of that. And then, of course, we want to be able to do comparisons. We want to be able to compare sort of sentences. So how similar are sentences, or how similar are pictures, for example, or how similar are sounds. And therefore, this is again very useful, because once we have a kind of a numerical representation of something, okay, some piece of information that we want to store, then we can do interesting things with that within a database system. We can look for patterns, we can look for similarities. How close are these patterns to each other? And therefore, this is why a database system is so useful and beneficial, because it gives us scale, it gives us performance, it gives us the ability to store vast quantities of information and be able to do these kind of queries and be able to look for these patterns. And we'll see examples of those as well when we do the hands-on labs. Okay, so SingleStore is a vector database. Okay, we have, like I said, supported vector capabilities since 2017. Now, on the market, you will see a variety of products. Okay, I'll get to that in a moment. But here are some of the kind of use cases. And I alluded to these just a few moments ago. Some of the things that we might want to find. So I'm sure you've come across sentiment analysis. Okay, very popular usage in machine learning and data science. You're looking for reviews of restaurants, for example, or particular products. When you go to an online shopping sort of mall, store, or wherever, you search for particular products. You might want to find, what have other people who have bought this product, what are their thoughts, okay, in terms of reviews, and then you might be interested to see, how many positive reviews there are, how many negative reviews, and so on. Other more complex tasks, for example, here on the left-hand side, find burglars in a video. Again, as human beings, we look at that picture, we can obviously detect certain signs there. That gentleman there, I assume it's a gentleman, but he doesn't seem to be up to anything good. Now, how do we make a representation of that in software so that we can then be able to do these kind of searches to look for these patterns to identify that this is a burglar in this particular image? Okay, these are kind of complex tasks that we need to deal with. Okay, so I've alluded to vectors already. Now take a look at this. Okay, so we've got a couple of things here on the left-hand side. Okay, so it's all about semantics. So take a look at this. Okay, so we have a phrase here, the very first thing that we have at the top. Okay, so this is an English sentence often used. Okay, the quick brown fox jumps over the lazy dog, right? So that is just a kind of a phrase, an English sentence, if you like. Just below it, you can see that we actually have a picture as well of a fox jumping over a dog. And so intuitively, we would think, okay, well, despite the fact that one of these happens to be just text and another one just happens to be an image, the fact that they are very similar, we would expect that if we represented these in some kind of numerical way, that would actually be true. And in fact, if we look on the right-hand side, here we can see that there are some vectors, as they say. These are kind of representations of these, both of the sentence and of the picture. If you look at the numbers there, they are actually quite similar. That's coincidental and actually correct, because if you think about it, again, we can see that those two things are very, very close, despite the fact that one is an image and one happens to be a phrase in English. The third thing at the bottom there that we have, I guess this is meant to be some kind of sound wave, perhaps. Okay, this thing here. This is quite different. I don't know what that sound wave might be, but presumably it's got nothing to do with foxes, nothing to do with lazy dogs, and nothing to do with jumping. But its kind of representation in terms of vectors and numbers, if you look on the right-hand side there, is quite different. Okay, so this list of values here. So intuitively, again, we would expect that to be quite distant. So if we were looking for, foxes and dogs and jumping, then we might find that our search reveals both this particular sentence, for example, and the photograph, the image that we have. Those would be, results that would be returned, versus the third thing there, which appears to be quite distant. So generally, if we look at how we measure how close or how far things are, then there's a couple of different ways that we can do it. And you'll come across this in the literature. Sometimes it's mentioned in documentation. Sometimes if you are a machine learning engineer or you're working in data science, you will know this already, that there are a variety of ways that we can test how close things are or how far apart they are once we have this kind of representation in terms of numbers. And two of the mechanisms that we will look at today are these on the left-hand side here, okay? So we will look at this thing called dot product, okay, which is one of the things that SingleStore supports. And the other thing that we will look at is this thing called Euclidean distance as well, okay? So these are two different ways that we can measure how close or how far apart things are. And then the closer they are, the more similar they are, okay? So that is very, very useful. Now, keep in mind, okay, the software, the database is doing all the hard work for you, but obviously there is a step in terms of getting the information into the database system and then asking it these queries using these dot product and Euclidean distance to be able to figure out, how close or how far apart things are, and then be able to return the results to us. And then we can then use those to do some further processing. Okay. All right, let's take a look now. Now, in the world of vectors and vector databases, well, over the recent past, you see a kind of a surge in these specialized products that just deal with vectors, okay? This kind of numbers, if you like, the numerical representation. The key thing is that the vast majority of them are fairly new. They have very limited SQL support. Okay, SQL is very useful. It's you tell the system what you want, not how to get it. The system goes away and figures out the best way to retrieve the data for you. And it's very widely used, lots of tools that you can use, immense amount of skill set. If you want to find somebody with good SQL skills today, you can do so very, very easily. Okay, so the fact that there is limited SQL support in these products, I seriously see that as a major drawback. These products are only built for vectors. But the thing is, in enterprise environments, you don't want a product that just does one thing, okay? Generally, you have a requirement to be able to process the data in many different ways, of which vector support is one of the requirements that you may have. You might require full text search, okay? You may require time series support, for example. SQL is important, as I've already mentioned. Lots of things in addition to that that you want to be able to do, and therefore having a product that only does one thing puts you into this situation where then you have to kind of glue together a variety of different products together to be able to accomplish or solve some business problem. That's quite challenging and quite a lot of work. And this is one of the reasons why SingleStore is called SingleStore, is simply because it gives you a lot of these capabilities in one product. Very useful. So no enterprise features, okay? Rather important, I would say, that you have these enterprise features. Scalability and performance, and things like interoperability. You can see there's a variety of these things that we've kind of mentioned on here. So customers, especially enterprise customers, need this kind of support, need these kind of capabilities. Very, very important. Now, moving on, in addition to vector databases, there are these things called vector libraries. So here you are not using a database system at all. So you may have come across some of these. I mean, things like Annoy, for example. So generally, these are built for high dimensions. They are quite memory hungry. They don't provide any SQL support, limited metadata support. Typically, they don't have things like create, read, update, delete, so-called CRUD operations that we have within a database system. But that might be okay. I mean, you may have a very small scale problem for which a database system is kind of overkill, if I can put it that way. And therefore, something like a vector library might be entirely suitable for that small scale problem. But the thing is, if you want to scale up, and again, you have enterprise requirements, chances are you are going to require a database system that not only supports the vectors, but has additional capabilities as well. Okay. And like I said before, we have a variety of customers that are already using vector support. And there you can see some famous brands globally that you should be able to recognize that are actually users of SingleStore vectors over the years. And as I mentioned right at the beginning of the presentation, the reason for vectors came about because of a financial customer, and I can't offhand remember who that was. It may well be one of these two that are on the bottom row there, the Bank of America or Goldman Sachs, I'm not sure. But they required this vector support, and that was the reason that it was added originally way back in 2017, and obviously has been enhanced and added to since that time. Okay, so now let's move on then. Building a GPT app with your own data. So a couple more slides to show you, and then we'll move on and start doing some hands-on labs. Now, with all this kind of ChatGPT, OpenAI, LLMs, you know, people are building these wonderful kind of bots, if you like, and intelligent assistants. Well, we've done exactly that as well. So we have something called Squirrel, okay? And you'll get a chance to use this as well, okay? Because once we start to use the notebooks, it is a feature that you can enable. So what we have done is that we have trained this system using our forums, our documentation, white papers, and so on, a variety of information that we as a company, SingleStore, own. And therefore, you can ask this system some question. For example, you know, how do I write a query to interrogate a table with a particular database system that has the following schema, for example, and you can describe the schema. And what this will do then is it will search the information that it has, and it will come back and give you an answer and make some recommendations for you. So in the same way that you kind of interact with ChatGPT or Bard, you can ask it a question, and then based upon the information and the knowledge that it has, it will come up with an answer for you. And this is trained specifically on SingleStore. So you can ask it anything outside of that scope, obviously it won't be able to help you. But if it's related to SingleStore, it will certainly do its very best and often come up with, you know, top-notch answers that will be perfect for you to use. So as I said, I'll show you how to enable this in your notebooks momentarily. But generally, the process that we adopt in terms of working with generative AI, or Gen AI for short, in terms of this kind of question answering or building these kind of intelligent chatbots and so on, and getting useful information out, which can apply equally to enterprise environments as well, is that we take some source material and we break this down into chunks. Okay, so this is the kind of the first step. From this, then, obviously, in order to be able to do something useful with that and to look for these kind of similarities, then we need some kind of numerical representation of that, so-called embeddings, okay? And this is the second step. And this is why we are going to use OpenAI today, but there are other LLMs that you could use, and open source as well, to get these kind of representations of these chunks. Then we've got some question that we want to ask, or some search string that we want to apply to the data that we have stored. And obviously, again, because we are going to use the software to be able to do that search for us, we need to convert that into some kind of vector representation as well. That's the third step here. Then we're able to look for this kind of nearest neighbor, okay? Find those patterns, those elements that reside within our database system that are the best match. And then we retrieve that, and then we can use that further. So we'll, in one of the notebooks that we will use, we will go through this process, we will retrieve the information, and then actually what we'll do is we will pass the returned results to ChatGPT and then ask it a question and see what answer it comes up with. So this gives us some additional capabilities here. And this can really extend the capabilities of these large language models, because remember, these large language models are typically trained on some data. In the case of ChatGPT, for example, it has a cutoff date. I think it was September 2021. So anything after that period of time, it doesn't know about. As far as it's concerned, that is the limit of its knowledge. So if you try and ask it something that happened after that period of time, it will tell you, I don't know. It's the future as far as I'm concerned. But we can utilize these capabilities here, these first 4 steps, and then give it some additional information for which we can then ask it some questions. And we'll do that in the labs. Okay, let's move on. Okay, and so the three kind of key steps, which is where the title for this webinar really came from: choosing a large language model, choosing a vector data strategy, and the search and prompt element of it. Okay, so essentially we're kind of capturing those 5 steps, kind of, if you like, to reduce them down to 3, but at a higher level, but abstracting this up a level or so. And so the first element of this is choosing an LLM. And so you have today, fortunate enough to have a variety of different options. We are going to use OpenAI principally because it happens to be, in my opinion, like the gold standard. Okay, it is the best, the highest quality. Others are available as well, as you can see down here, in terms of open source. Okay, there are other possibilities too. Llama 2 as well. Facebook recently released that. That's something else that we can utilize as well. And then in terms of the, giving this LLM long-term memory, if you like, persistence, something it can remember, we need a database system. Okay, so this is where a vector store comes in. And this is particular why SingleStore is very useful to this. And as you saw from the graphic that I showed you near the beginning of the presentation, I mean, there's a lot more that we can do as well in terms of streaming data in from other sources. We may use it for analytics as well, for example, and working with SQL queries along with other capabilities as well. So this is one of the steps that we need. Choose a vector data strategy. Now, here's an example. This is actually a real-world example where a customer was interested in finding the top K items in a particular category. Okay, it's one of the sort of search strings that they were trying to apply, and that's fairly easy to do if you are working with SQL. And if you're fairly familiar with the way that SQL works, you know that it's got quite a wide range of capabilities. It's an awesome language in terms of its power and capability. And if you're familiar with it, you have some expertise with it, it's very easy to write this kind of query. And there's an example of how we would solve this. On the left-hand side, this is the kind of use case where the customer actually tried to do the same thing. And I can't show you the result, okay, because as you can see, it shows you a nice big X here because the system couldn't answer it. It failed, okay, so it couldn't do this. As a very straightforward kind of query to do in SQL. And the other thing, as you can see down the bottom here, SQL gives you all these other wonderful things as well in terms of filters, ranking, joins, aggregation, grouping. Very, very useful for enterprise applications. Pardon me. And then the last step here, the search and prompt. And again, we'll look at an example of this. Okay, so remember we talked about kind of chunking up the data, creating the embeddings, asking questions. And so if you've worked in this space recently, you will have come across something called LangChain, which is an awesome framework that allows you to utilize a wide range of what are these called, agents and chains and things to work much more effectively with LLMs. And SingleStore now has an integration with LangChain as well. So essentially, the framework abstracts away the storage to the database system, your long-term memory, if you like, and it gives you the opportunity to focus much more on the high-level kind of business problem, if you like. And if we have time, okay, we can go through an example where we'll take a PDF document, we'll chunk it up, okay, break it down into smaller parts. For each of those smaller parts, then we will obtain the appropriate kind of embeddings, okay, those arrays of numbers, numerical representation of what that text is. And then once we've got it in the database system, okay, which is SingleStore here, as you can see, the user can typically then ask a question. And typically that question can be asked through, say, a notebook, or it could be like a program. We interrogate the database system. we find the appropriate match documents that meet that requirement, and then those match documents can then be input to an LLM, such as ChatGPT, for example, and then we can get back some answer. Okay, so this is a great way and a very easy way to utilize this. Again, we'll see elements of this in the hands of on labs momentarily.
Akmal,
Okay, there we go. Yes, Shweta.
so before moving forward, actually, from your few steps before, I think the slide 2021, people have a few questions on the size of the byte size for a chunk, embeddings, etc. So the first question, I know that we want to move ahead to the hands-on labs, but I realize that it is important to answer some of these questions to clear that out, because people would want to move ahead with a clearer request.
Yeah.
So the first question is, how large byte size is for a chunk?
These will be defined by the particular LLM. So if you go to the OpenAI website, they provide information on the different models they have, how much text you can send them, the sizes, all of this is available. We can find the web page and share that. Okay, that'll be a lot easier. And again, it depends on the particular large language model you're using. Each one has its own particular, in terms of what it offers and the capabilities that it offers. So for open source, for example, might be a little bit more limited. OpenAI, for example, has a wide range of models it provides for all sorts of different scenarios. And again, the number of tokens that you can use, how large the text, and essentially the cost, okay? Because with OpenAI, you are using a third party and you are paying for the privilege of using them. What I would say is that the cost has come down considerably. So these are factors that are very important, as you've rightly identified, Shweta, and as the questions have come forward. But that's a fair bit of detail, which it's easier just to show the web page. Okay, we can find that, for example, and share that. And I can do that once we get people up and running and creating their workspaces.
So you can look at some of the open questions here. Do you think any of those are right now crucial for us to address, or we can just move ahead?
So Anonymous asks, how large byte size of a chunk? That depends, okay? Like I said, we'll find the details because it depends on the model and so on. And you can control in terms of, for example, one of the PDF documents that we have, the example, is to break it down into 2,000 characters. That's the size of a chunk, okay? And so, for example, if I've got a document that's 13,000 characters long, then obviously 2,000 into 13,000, and you can see roughly how many pages that would be then, say approximately 7 to 8 pages, okay? So that's entirely up to you. You can decide how much you want to divide that up into. Another anonymous question. So first we store in the chunks and then match the nearest neighbors and then get the answer on the basis of analysis. More or less, yes, that's right. So what you're doing is you're dividing. So imagine, for example, a huge document that you've got. You wouldn't store that huge document necessarily as a single kind of chunk. I mean, that's going to be very large for you. So it's better to break this down into smaller components. Again, the size depends on what you want. And again, the choice of LLM model may dictate that as well. But these are factors that you decide upon based upon usage patterns and so on, your queries, what you're going to ask. And then once you've done that, you determine and get the embeddings. What sort of queries do you want to ask? Okay, you need the embeddings for the query. Okay, and then you can do the k-nearest neighbor within the database system, either using find the nearest neighbor. Okay, find the best match, Euclidean distance or dot product. Okay, let's have a look.
Yeah, so I think there are a few more, and we can take the rest. I don't think these are crucial right now. Do you think these are crucial? We can wait till the rest, because there's one question on the matching text with type or phonetics. I think
yes,
Ankur,
yes, sure. So let's just do these do these three. I'll do my best to answer these. So can I match text with typo or phonetics error in SingleStore? Well, the thing is, if it's got a typo, I mean, it's one of those things. The quality of the information you put in, I mean, that's going to determine the quality of the answer that you get out. if it's got errors in it, I mean, you will get an embedding that's generated for that. That is, you know, whether you intended that or not, unfortunately, that is a step that you will have to take in terms of kind of ensuring that what you put into the database system is what you intend. And therefore, you know, I've often heard it said that data scientists spend most of their time actually cleaning data, right? It's one of those steps that we don't show here, where there's a kind of a certain assumption here, but yes, that's absolutely an important step. So it really depends. I mean, if there's an error, embedding is still going to be generated. Maybe the answer that you get back is not what you expected, but that's something that you have to look into.
All right. Thank you, guys. I know that you are very, very curious and there's so many questions pouring in. So let's just take at the end, because I know we are halfway through it.
Yeah,
yes, go ahead.
Yeah, I just wanted to add to Akmal's answer from the full text search perspective as well. This was semantic search perspective, but also from the full text search perspective, if you're looking for a keyword with a typo, there is fuzzy search ability in our full text search piece. I will share that over the chat, the link to the documentation. Thanks, Akmal. Thanks, Shweta.
Yes.
Okay, perfect.
Yeah, and Anka's got a great point there as well, Shweta. So the thing is that with the full text, if you think about it, again, this is one of the benefits that SingleStore provides. And we've actually demonstrated this for a potential customer not so long ago, where they were interested and said, well, look, okay, you can store vectors, you can store documents, but what happens if we want to combine that with some full text search as well? And so because we have Lucene, the Lucene open source engine as part of our full text offering, we can actually do that too. So that is something that, you know, it goes beyond just relying upon the vector search. Using the fuzzy searching, as Anka was saying, that gives you an added bonus and added sort of confidence in terms of what you're getting back. And maybe, you know, it could be that for the full text is your primary search mechanism, and the vector search is something that could augment that, or it could be the other way around. Okay, but essentially you've got two very strong capabilities there that could help in this scenario.
Amazing. I think perfectly answered. So thanks, guys, for taking this live. I know there are so many questions pouring in. Let's do that at the end, and let's go to the hands-on session. There's a critical part of why we are here. We want to learn something hands-on. So let's move on to this. We are tight on time as well. Thanks.
Yeah, that's great. So awesome. Okay, so let's have a look then. So first thing, hopefully all of you have followed the links, and you've the bit.ly link. Do you want me to show it again, Shweta, or are we good? I assume you've posted into the chat there as well for people to follow and create their accounts. Is that okay? Let me just check the chat. So there's quite a bit of stuff there. Let me have a look. Let's have a look. Oh, yes, you've put the bit.ly link into the chat for everyone. That's great. And that's great too. Will you share the link to the where you've put the notebooks, or do you want me to do that?
I can do that, sure.
Oh, okay, that's great. All right, so meantime, let me get people up to speed then. So once you've created your, and so let me make this bigger here, okay? And again, team, let me know if you can't see my screen, okay? Or if it's causing some difficulty. I'm speaking about something that you can't see, just let me know, all right? So once you've created your SingleStore account, essentially, and you've logged in, this is what you should see, something like this, okay? So you've got like a home page, and then on the left-hand side, you can see there's a kind of a navigation pane, okay, which has got a variety of sections. I'm just drawing these arrows here at random, okay, just to show you what we have. Probably easier, actually, why don't I do a box instead, like this? So you can see there that we've got a kind of a left nav here, okay? So that's great. Okay, and what you need to do is you need to create a workspace. And to create a workspace is very, very easy. So if you just look on the left-hand side, you'll see that there's a section marked cloud, okay? And again, let me draw a box around that, like so. Okay, now in my example there, you can see I've already got something running. I have a workspace configured here this thing here, okay? And you're going to have the same thing done as well. So can you see there's several ways that you could create your workspace. Either click on this thing here that says group, or you could go on the right-hand side and it says workspace group there, okay? So either one of those, try those, okay? So I'll do this as well. So if you click this, it will give you group, okay? And you should see this page like so. My recommendation is just take the defaults, okay? No need to change these. If you really want to change the names, I mean, you can do so. It makes no difference, but just take the defaults, okay? So for the first step, you see that there's a group name. That's fine. I'll just leave it at group 2 because my group 1 is already created. For the cloud provider, please ensure that you are using AWS, okay? It's rather important. You'll see a couple of different options that are available in my environment. That's okay. But for the region, try your best to do the US East one, North Virginia, if you can. If I look at this pull down, you can see it's got a variety of options. And so if you are in Singapore, Asia Pacific Southeast one is a possibility. You can choose that one as well. If you're India, you can see there's Mumbai is offered as well. So there's a couple there that are global. All I would say is that US East one will be a little bit better for us because of the co-location in terms of our workspaces and the notebook environment, all right? That will work fast for you. So it would be better if you can select that. If you have some problem with that, then by all means, select one of the other options that you want to, depending on your geo, that's fine too, okay? And so once you've got that down at the bottom, and my bottom is blocked by Zoom, so let me just do this. You'll see then at the very bottom, you've got a box marked next. Okay, so just do that. And then you see here, it says create workspace. So again, please just take the default for the workspace name. No need to change that. Keep the size at S00. That's absolutely fine. Okay, there we go. This is perfect for learning, but as you can see, there is an edit button here. Okay, so if I just click on this, you can potentially, what's the largest workspace that you can create? Well, it's an S384, which has got over 3,000 virtual CPUs, 24 terabytes of RAM, and it's very expensive to run enterprise customers, right? You'd use that if you really have a big requirement. There's no need to enable any of these. You don't need SingleStore Kai, and you don't need the Martech dataset, all right? So ignore those, leave those unchecked, and then just click the button that says Create Workspace. Okay. Now, because I already have something running, I won't do that, okay? I'll just go back, and then just go back here. And then once your workspace is provisioned, okay? So can you see here, all I've done is I've just selected the name here, which in my case is called Group 1. And then this is under Overview here, the Overview tab. You'll see this workspace here. Mine's already ready to run, ready to go. So you will see like a bar that shows you the progress in terms of how far it's got to create. It should come up fairly quickly, okay? And that's what you need to look for, okay? And one of the options that I think because of time, we may not have the opportunity to do that, but I'll show you a little bit later on, okay? So that's absolutely fine. But there's nothing else that you need to do here for the moment. Just wait for it to provision. And then in the meantime, what you can do is that you can, let's have a look. If you, again, look in the left-hand navigation pane, and let me do a box here just to draw your attention. Under the section that says Develop, you can see one of these things, it says notebooks in bracket, text there after it, preview. Okay, so if you click that, here you can see that I have a whole bunch of notebooks here all ready to go. And what you need to do then is in the top right there, you can see that there is a pull down. Okay, currently it says new notebook, but if you pull the arrow there, you can see one of the options that says there, import from file. So Shweta will share the link where there are a number of notebooks that reside. Okay, so these are IPython Jupyter notebooks. So just save them to your local drive. I think there's 4 of them that are initially shared with you. I think that's those are the key ones that we will have time to complete today. And so all you need to do then is just, if I click on import notebook, I will get this box, and it will just ask me either drag and drop the notebook to the box here, or you could just say browse files, for example, like so. And in this particular case, these happen to be on my desktop. So there are 7 there, but you know, if you pick the 4 that Shweta has shared with you, 1, 2, 3, and 4, and then just say open. Now it's going to give me an error because it says that file already exists. You have the option just below here to select whether you want it to go in your kind of personal space or a shared space. It doesn't really matter. You can choose either. Okay. The shared space is beneficial if you plan to share this with colleagues, because what you can do then is you can create a link to that notebook and then send that link to your colleagues, and then they can access that notebook as well. But they can only do so if you share it with them through the link. Okay. So just load those 4 notebooks in. All right. And once you've done that, I've got these here, as you can see, in my personal space. Okay, these are the 4 that we want. All right. And if I just pick the first one then, which is the iris KNN plot. So the first 3 notebooks are quite simple and straightforward. Okay, so just to give you a little bit of a sort of a better understanding of what we're trying to do here. And then what we do is we combine the ideas from these 3 simple notebooks into number 4, which is quite substantial in terms of what it tries to achieve. Okay, and there we interact with ChatGPT as well, and we do so using the embeddings and you know, give it some new information based upon some data that we have, and then we see what its response is in that scenario. Okay. All right, great. Now, hopefully you all have also, let me just minimize this a moment. Let me just get this, that you will need an OpenAI account. Okay. And you can, if you haven't signed up for one, it's very straightforward and easy to do. Okay, so you just go to, I can put this into the, okay, there we go. Okay, so that's shared there. And once you're in, so essentially, as you create the OpenAI account, you will get $20 of free credits. They may require you to use a mobile phone. That's only used for one thing, and that's just to verify your identity. So it doesn't matter where you are in the world. If you are in India or if you're in Singapore or any other country, I mean, there's no cost to you. They will just send you a text message or something just to confirm, and you use that to as part of your account creation process. And then once you've created your account, essentially it will look like this, something like this, okay? And then one of the options that you have on the left-hand side is to create an API key, which is what you need. So here you can see I've done one already, okay, for myself. which I use. The last time I used it was actually yesterday. Now, in case you're wondering, how much does it actually cost for the labs? Well, I figured it out, and OpenAI keeps reducing the costs of its services and the different models that it offers. So even running all of the notebooks that we have here, the cost would be, I think, about 1 US cent or something like that, because the quantity of text that we are dealing with is actually very, very small. So much of the embeddings have actually been generated already for us by OpenAI, and we're going to use that as a kind of a way to speed through and A, save money, and B, just do it faster, okay? Because they've already done that for us. So that's the main thing, okay? So hopefully all of you have managed to load up the notebooks one by one. Now, I did promise you something. I mentioned squirrel to you. Can you see that just above the notebooks here, it says here, code with squirrel. And by default, it's switched off. So you can enable that. You can switch that on. There we go. And what it gives you is this kind of little chat box here. Okay. And so you can ask it a question in here and then say generate. And this is, by all means, anything specific to SingleStore, you can ask and it will give you a response. If you ask it about the latest news or, you know, what's happening around the world or some other technology that it doesn't know about, it won't be able to help you, okay? Because it's trained only on SingleStore. So that's very useful if you want to learn and you want to ask, you know, what is the particular syntax for this command, or give me an example that shows me how to do this or how to do that, for example, or how do I store JSON in SingleStore. It will give you examples of all of those and links to appropriate resources. Okay, so that's a great way to get started there. All right, so let's move on a little bit then. Okay, so let me disable this. Okay, so I get a bit more of my screen back. And so very quickly, I mean, this first example doesn't require any OpenAI, doesn't even require SingleStore, but we are just using this notebook environment. So very quickly, just to show you this k-nearest neighbor, okay, which you may have come across. Again, we mentioned it in the presentation. There is something called approximate nearest neighbor, ANN, which is similar but faster, okay? So it gives you the results much faster, but may not be as accurate. But this is very useful because it's commonly used in data science, machine learning, and it's rather popular and well known. So the notebooks that you have, I've pre-run them already for you. So for example, if you don't particularly want to execute the code yourself, but you're happy to follow along, you can do that. If you want to run them, we can do that too. So what I'll do is simply go here and clear all the output so that I can run this with you. Okay, and so the first thing we do here, we just install a couple of libraries, scikit-learn. So those of you, again, familiar with machine learning, it's something that I'm sure you've used a lot of. It's one of my favorite, packages and libraries, basically because it's simple but very powerful. And then here we just use matplotlib. Okay, so I'm just doing Shift-Enter in each of those code cells. All right, so we are going to load in this iris dataset. So the iris dataset, very famous dataset, 3 different species of flowers, and it's very small, only 150 rows, but it's very famous because it's often used for a lot of machine learning examples. And it's great because it's tiny, doesn't require a lot of resources, but it's very useful just to work with it, and we can apply it in a number of different ways. We can try different things with it, and we get results back very quickly. So that's the key benefit here. So all we are doing here is just setting this up, creating a color map, okay, so that we can see the different types of species. We are just taking the opportunity here to read the data in, and I'm just showing the first 5 rows of the data. So this is coming from scikit-learn. So as you can see, we've got a number of columns of information here. We have sepal length, sepal width, okay? So that's to do with the kind of the green part of the flower. Then we got the petal length and the petal width, okay? And those are all in centimeters. And then the last column here is the actual species. So we can see here that in this particular case, we've got all 5 of these are Iris setosa. So that's fine, okay? So there's just 5 rows from the 150. So just to show you a little bit about the structure there. And then the next thing we're doing here is simply creating a color plot just to illustrate what is the one nearest neighbor. So this is kind of doing it in 2 dimensions. We are taking 2 of those columns, okay, the width and the length, and we are plotting these on this map. And if you look at this, you can see that one species of flower is very distinct. That's the blue one, the setosa. The 2 others, the versicolor and the virginica, well, mostly they are kind of separate, but you can see elements of overlap there. So this is why this is a great kind of data set for machine learning, because often when we want to do sort of build classifiers of things, we try to train it on some data. And sometimes the model doesn't get it right, okay? There's a kind of, it gives us a confidence level, but doesn't necessarily guarantee that it's going to be accurate all the time. And so this essentially, you can see these kind of boundaries as well between these. Let me try and draw around here. Here, for example, okay? So this, everything on the left-hand side here, you can see is going to be this particular species. And there you can see 50 of those blue dots there. And similarly, on the right-hand side, you've got a similar thing here. So essentially, what we have is that if we have, say, one of these species, a flower from this particular species here, which happens to be setosa, if we look at the other kind of neighbors, if you like, that are close by, well, they're all the same. Yeah. On the other hand, if we take a look on the other side here, let's take a look. Let me try and pick something. In this particular area here, let's try and draw around that. For example, down here, we can see that there's some elements of versicolor, and then we've got virginica as well. And so these are kind of boundaries, if you like, decision points. If something is kind of on one side, it's closer to one species. If it's on the other side, it's closer to another species. It's just breaking this down and giving us a visualization, a better way to look at this. Now, the thing is that this is 2 dimensions, okay? Remember that we actually had 4 columns of data. The problem is that modeling that, representing that on a 2-dimensional kind of graph is rather difficult, okay? This is a challenge. I mean, once you get into these multi-dimensions, it's extremely difficult to kind of visualize this, but this is great just from an illustrative point of view, right? So that's just looking at what is the one nearest neighbor to each of these data points, okay? So rather important. And then quickly, if we have a look at the next example just below, the next visualization, this does it for 3. This says, okay, what are the 3 nearest neighbors to this? And again, you can see this is a very important kind of distinction here, the boundary here. Again, setosa does pretty well. I mean, it's quite distinct. So no change there in terms of where it lies, although we see that the middle area here has kind of changed a little bit if we compare this to the previous one, simply because now we are considering not what one of the closest flowers is, what it might be, what species it might be, but we're looking at 3 of them that might be close by, and then deciding upon this decision boundary based upon that. So that's kind of a useful way to kind of visualize this, but just 2-dimensional, okay? Just taking 2 of these particular characteristics of this data set. Okay, now let's take this a step further then, okay? So hopefully that's good. You've all got that working. And now I've just clicked on the second notebook there, okay? This is the embedding example. And again, I am going to clear this. Clear all outputs. Right, now the reason I kept this here because I need to enter in my OpenAI key, which I'm just going to copy from here. Okay, and let's just maximize this again so you can see a bit more here. So in this example, what we're going to do is we are going to use OpenAI, and we are going to construct a couple of sentences, and I'm going to give you some demonstration of both the dot product and the Euclidean distance, kind of to show you how we can determine, whether things are close together, or far apart. And so here it will prompt me for my OpenAI key, which I will paste in here and enter. Okay. So again, if you haven't got that yet, don't worry. I mean, you can follow along, and this is fairly short. There's not much to this. And then what we're doing is we are going to call this OpenAI embeddings. Remember I mentioned LangChain. So LangChain is making this task a little bit easier for us. So we are, rather than having to write lots and lots of code, we simply call this. And here what we see are 3 examples of text. Okay, so remember we looked at this earlier. So the quick brown fox jumps over the lazy dog. That's the first sentence. Second sentence, I can see a fox jumping over a dog. And then the third sentence here, the weather is wet and cold outside. Now, again, intuitively as human beings, we can kind of sense that, well, the first sentence and the second sentence, very similar. They talk about a fox and a dog and jumping. So we would think that, yes, they relate to the same thing. Whereas the third thing is entirely different. It's talking about the weather. So let's just create these variables. And then what we're doing here is we're calling OpenAI to give us the embeddings for each of these sentences, give us the kind of the numerical representation of what these are. So we're calling this is now going to a third party. It's returned the embeddings, and then we can actually take a look at part of the embeddings. I'm not going to show all of it, okay, because it's just too long. We'll just look at the first 5 in each case, okay? So there we go. We're just looking at the first 5 entries here. So can you see these numbers? So each of these 3 sentences here is represented, and there's the first one. Okay, so there's the first 5 kind of numbers of the vector, if you like. There's the second sentence. Same thing. And then there's the third sentence. There we go. I think it's only letting me show the, so when I'm clicking my button, it's kind of trying to display all of them, but only giving me the first one. But intuitively, again, if we look at the first 2 here, we can see that they seem to be a little bit more similar than the third one. Right? It's just a quick scan based upon 5 entries, okay? And the 5 entries, again, I've just limited it here, as you can see, 5, 5, 5. Okay, you're welcome to remove that restriction and look at the entire embedding if you want to, but expect a long display and a lot of information coming out there. So that's just to show you what this actually looks like. Okay, and then in our slide deck, we talked about 2 ways that we could kind of test how close or how far apart things are, the dot product and the Euclidean distance. So if we take a look at the dot product, we'll first load this NumPy, okay? And then what we'll say is, let's find the dot product between the first sentence and the second sentence, return the value, and we can see that actually the match is very good, okay? It comes out to 0.90622. So that is approaching 1, okay? 1 would be a perfect match. 0 would be the opposite, okay? So now we'll compare the first sentence to the third sentence, and we can see that the value is lower, 0.77. So those are much more distance. The 2 sentences are further apart. And then we can take the second sentence and the third sentence again, and take a look at the value there, and there again, you can see it's 0.78. So again, using dot product in this case, we can see that higher is better. The higher the value that we get, the closer things are. And again, just through visual inspection, looking at those sentences, we can identify that indeed, we see a lot of similarities between the first 2 sentences and not much between them and the third sentence. So this is one way that we can kind of test to see how close or how far apart things are. Another way we can do this is this thing called Euclidean distance, okay? So this is another way that we can test this. So again, I've written a little bit of code here, a function just to calculate that for us. And then we're just generating a couple of arrays here based upon the embeddings that we've received back from OpenAI. And then we can test the Euclidean distance between essentially the first sentence and the second sentence, and it gives us a value, which is, in this case, 0.433. We'll test the first sentence and the third sentence, and it comes back with a value of 0.67. And then for the last case there, we'll test the second sentence with the third sentence. And again, we get a value of 0.65. So in this case, lower is better. So the lower the value, the better it is in terms of how close things are. The distance between them is smaller. Okay, so this is better. So again, intuitively, just looking at the numbers, we can see that the lowest value we have here is 433, which again makes sense. Having looked at the sentences and having done the dot product as well, we can see that the results are in agreement. We've got something that works well for us. So we can use this mechanism. One or both of these would be fine. And either one of these, we'll use Euclidean distance in the next quick example, and then we'll put all of this together finally, okay, in the big example that we'll finish off with, and demonstrate how we can use all of this together. Great. Let's now load in the third notebook. Okay, so this one is now using a little bit of SQL. So again, nothing that you need to set up, nothing to do. We're going to use this magic command here, okay, which is in this cell here, to run some SQL code directly. So what we are simply doing here is we are just creating a database. We are creating a table. The table has got two columns. One will store the vector, and the second will store the species, okay, the species of flower that we have. And if we run this, again, just do Shift Enter. I didn't clear it this time, but that's okay. It'll be fine. Okay, there we are. That's done. It's created the table for us and the database. And now we are just going to load this data in. Though this is a rather crude way to do it. But what we are storing, if you look at this, there's 150 rows there. That is all of the entire iris data set, okay? So you can see that we've split this up into two parts. And we've got one part, which is, if you like, the vector, okay, which contains sepal length, sepal width, petal length, petal width. All four values are stored in this kind of array. And we are going to store that directly in the database system. And then the second column here is our species, okay, which is the associated species with that. This happens to be Iris setosa, for example. And the way that we are going to store this in SingleStore is using this thing called JSON array pack. Okay, so this is a very efficient way to store the data and be able to give us this ability then to do these kind of vector operations upon the data, such as dot product and Euclidean distance. And so if we just go down to the bottom here, okay, to the end, and look at the very last row here, I'll just simply do Shift Enter to actually enter these values into that table. It's done that for us. And then what we can do here is say, okay, let's get 5 of these values back. Let's take a look at any 5 of these using SQL. If we run this, it returns these 5 values. And you can see here that, yes, we've got the vector column and the species column. In the species column, we have Iris setosa. In this case, it just, remember, this is just picking these at random. And then there you can see the vector representation. So this is what it actually looks like internally. Gobbledygook, garbage to us, okay, not human readable, right? But this is the kind of internal representation that SingleStore has of the data that we have stored, that array of values. Wouldn't it be useful if we could actually see those in a slightly better way? Well, there is. And so just above, we did JSON array pack. There is something here that we could use JSON array unpack. And so we use that to retrieve the original values. And there we've got something more sensible now. Okay, so you'll see that there are some rounding errors here. Can you see? Rather than 3.4 there, we've got 3.40000001. It's just the way that it's stored it. It's currently, I think it's 32-bit floating point. So this is why we see these sort of slight difference there. But in terms of accuracy, I mean, it's enough. It's good enough. So this is showing us the vectors that it's actually stored. All right. And then what we can do then is we can ask some questions. We can say, okay, in this particular query, we'll say, I want to interrogate this particular table, and I want to find the Euclidean distance. You know, take this particular column called vector that we have, and then compare it against this particular value that I want you to test. And the Euclidean distance, the distance between them must be 0 in the sense that it's a perfect match. So remember, dot product, higher is better. Euclidean distance, lower is better. So 0 would be a perfect match. If you are sharp-eyed and you look at this set of numbers here, you will see that this is the very last row from the values in the SQL that we entered. So to compare this to the very last value. Now, we would expect this to return a correct value because it already exists in our database system. Therefore, if we ask it, return a Euclidean distance of 0, match it against this thing, and we know this thing already exists, it should return it and give us a perfect answer. Okay, sorry about that. It's asking for a database up the top here. Okay, so we just need to select IrisDB up here. Okay, there we go. And we should be able to run this. There we go. So it's given me the answer of Iris virginica here. Now, is that correct? Well, if we scroll back up, take a look. Let's look at that very last row that we've got here, set of values that we entered. And indeed, we can see that the match is this. So it's been able to find that perfectly, and it's an exact match. So we get back the species. Okay. In the next query, then we could say, all right, rather than just finding me a perfect match, just find me the 5 nearest ones that you can. And this goes back again to that nearest neighbor kind of concept. Okay, so here we've limited the answer to 5. And so obviously we would expect that one of these is a perfect match, which is this first one, 0.0, okay, which is again Iris virginica. And then it's given us some additional values here, the next 4 closest ones that it's able to find. Okay, so this one is a 0.28, 0.316, okay, 0.33, 0.33. So these are the next 4 closest ones, and the species, again, happens to be Iris virginica. So this is using Euclidean distance in this case. Okay, this is for data that already exists in our database systems. What happens if I enter in something that it doesn't know anything about? Suppose I put in a new value. Let's say I make up something here, which I've done. So in this query 3, this set of numbers here, 5.2, 3.6, 1.5, 0.3, does not exist. I just made these numbers up. And so all I'm doing is saying to the system, okay, see what you can find in terms of matching something that is close to this set of vectors that I've given you as per the Euclidean distance, and get me the 5 best answers, the 5 closest values that you can. And if I do this, it returns me the 5 closest values. And again, you can see here that in this particular case, obviously there is no perfect match, okay, because I've made these numbers up. The closest value that it's been able to get to that is with a Euclidean distance of 0.14, and the species happens to be Iris setosa. And in fact, the remaining 4 are also Iris setosa, although you can see the distance is increasing slightly each time there. So this is simply giving us the 5 closest to that particular set of coordinates that I've entered. And again, we can just limit this to say, okay, rather than giving me 5, just show me what is the closest one that you have. Again, similar to that KNN example we looked at a little bit earlier on. And I'm not interested in the numbers, but just simply give me the name, and it is Iris setosa. Perfect. Okay, now, so we've seen Euclidean distance, we've seen dot product, we've seen KNN, K nearest neighbor. Okay, so let's take these concepts and then put these ideas together into this notebook number 4. Okay, so this is the sort of big substantial example that we've got. And again, what I'll do is I'll clear all the output this time, just so that I have a blank blank sheet to work with. Hopefully I've my copy and paste of the OpenAI key is still current, but that's fine. So if we start at the beginning here, again, we just install the OpenAI. Okay, that's done. The particular language embedding model that we are going to use from OpenAI is text embedding ADA 002. Okay, this is very efficient. It's relatively cheap, okay, in terms of cost. And the cost of this, like I said earlier, keeps going down all the time. And then we are going to use ChatGPT as well. And for that, we're going to use this GPT 3.5 Turbo. If you are fortunate enough to use GPT-4, well done. At the moment, they charge money for that. Okay, so well, a lot more money, but we'll stick to this. This will be fine. Okay, so we'll just enter this. We obviously need here again to input our OpenAI key. So I'll do that here and save that. And just browser is just asking me to save that. I don't need to do that. Okay. So here, what we are doing then is we are going to use ChatGPT. And what I've done here is I've given ChatGPT a role. I have told it, you are going to be a helpful assistant. And what I want to ask you is, tell me who won the gold medal in men's curling in the Winter Olympics 2022. Remember, from our previous discussion, ChatGPT's cutoff date for its kind of what it's been trained on was September 2021. So let's see what answer it gives us upon this. So let's execute this. And it says here, I'm sorry, okay, but as an AI, I do not have real-time access to current events or sports results. However, you can easily find the answer by searching online or checking reliable sports news sources. So essentially, basically, it's telling us it doesn't know because it's something that for it is in the future, okay? Obviously, for us, it's in the past, okay, because we've moved on some period of time, but this is the situation. And so what we can do is we can actually teach ChatGPT how to deal with this, okay? So again, we'll just load some libraries there. Okay, just matplotlib, scikit-learn, tabulate, tick token. These are sort of standard things. We'll get our pandas. We go, okay. And then what we'll do is we're going to obtain a file here from OpenAI, which very helpfully is a Wikipedia article of the Winter Olympics from 2022. And what OpenAI has done is that they have chunked up the text. They have created embeddings for all of those chunks, and they put it into a CSV file. So if we run this, it takes a moment or two to download, okay, because it's about 200 megabytes. And then once it's downloaded, okay, we can take a look at the structure of that and see what's actually inside the file itself. Okay, so this just takes a moment or two. Okay, so in terms of time, we're doing great. So this won't take too long to finish, and then we'll open it up for questions, okay? And then we'll have time for some discussion as well. And actually, Shweta will have some additional resources to share with you, okay? Some additional notebooks that you can try out in your own time, which we didn't have time to go through today. But there we are. The file is being downloaded successfully. That's great. And then what we need to do is we need to do a little bit of sort of massaging of that to get the data into the right format for analysis. So this is just converting those back to sort of lists, okay? Because remember, it's a CSV file. So as far as the system is concerned, it just treats it as text. But what we want to do is to say, well, actually, we want to treat these as a kind of a list of numbers so that this operation takes a few moments, okay? Just wait for that. There we go. And then what we can do is we can take a look at the data frame. What does it look like? Well, here is what the structure looks like. It has got 6,059 rows and 2 columns. And the 2 columns that it has, one is text, okay? And the other one is the actual embedding. And the text is the text from the Wikipedia article. So again, you can see here, we're only seeing a part of it. because otherwise if you try and display all of it, it's quite long. And again, if we take a look at the embedding, again, these are the kind of numerical representations, the equivalent of what that text is represented as these arrays, these vectors. All right, so that's what the structure looks like. So in this case, we didn't have to spend any money creating these embeddings. The embeddings are already done for us as part of this file, and that means that we can use it straight away. Okay, so we'll just run this to show us a little bit of information about what's there, which we already know, that there are 2 columns and there are 6,059 entries, which is correct. And it just gives us a bit more information in terms of how much memory it's using. All right, that's great. Now, that's fine. So what we want to do now is to take that CSV file, we want to store it in SingleStore, okay, which is what we're doing here. So we'll create a database called Winter Wikipedia. Okay, that should just take a moment. There we go. And then we're going to create a table to store both the text and the embedding. So as Anko was mentioning earlier, because we have full text search and we can store text as well, there is something in addition that we could do with SingleStore that isn't possible with a lot of these pure vector products, is that we could create a full text index as well. I mean, in this particular example, we're not going to do that, but we are storing both of these columns into the database system. And the structure here is 1 column is text, 1 is embedding, and you can see that the embedding is of type blob here. We are also creating a primary key. We don't need to necessarily, but that's fine. That's the way that this particular example is structured, and that's fine. Okay. Now, that's the SQL part. So we want to access through Python. So we get the SQL Alchemy. And then at the top here, you can see that there is this pull down. So from here, just make sure that the database is selected is the Winter Wikipedia here. Okay, before we go any further, otherwise it will give you sort of errors. And then the next thing we do here is essentially we are just inserting that data into the database system, storing those embeddings, storing the text. And here you can see we are using the JSON array pack that we previously used. And basically this just iterates over the data set, takes a moment or two. Oh, it's given me an error there. Let's just see what doesn't it like. Let's take a look at this. You can see quite a long-winded error. Okay, parameters doesn't seem to like that. Okay, let me just try this again. Okay, let's just execute this again. We'll try this again. If it fails again, what I'll do is I can switch to the backup. All right, so it seems to be happier this time, and you can see over here in terms of the numbers. Okay, so that seems to be better. I think in this environment, the reason why I asked you to use US East 1, North Virginia, I think, was because the co-location of this notebook environment and the workspace. So here you can see it took less than 30 seconds or so approximately to store that. Okay, there are faster ways to do this as well, by the way, but it's something that I need to look at in terms of optimization. If you are doing this from somewhere else in the world, it might take a little bit longer, okay? So be patient, okay? If it's not quite loaded, that's fine. And then here, what we're doing is we are going to create a function here that will take in some information that we want to search for, and then we are using this dot product here, okay, rather than Euclidean distance, and then finding the best matches. And the way that we are going to call this particular function is that we want to search for curling gold medal, okay? That is our search term. And what it does within the function here is that it makes a call to OpenAI, okay, this particular code here. get embedding, okay, with the query that we pass in, the curling gold medal. It gets an embedding for that, and then it uses that as a way to compare against what it has in the database already using this JSON array pack. Okay, you can see the code just below there. So that's what's happening there. Okay, so let's do that. And then we'll display the result. So you can see that, I mean, that's very fast. It returned almost instantaneously. And remember, this is dot product, okay? So higher is better. So in this case, the best answer, the best match it could come up with was with this kind of relatedness value of 0.879. That's the best we could do. And you can see the result just below as well in terms of the particular piece of text that it's been able to pull back. But remember, the comparison is against the embeddings. We're simply pulling back the text part of it here as well, just to see what it's got back. And because we aren't just doing one, but we are interested in 5, if you check the SQL code just above here, okay, it's limit 5. So if we scroll down, we can see that there are other values that have been returned here as well. So here's a relatedness value of 0.872. Okay, and there's the result for that. And then the other 3 below, it's 0.869, 0.868. There's quite a lot of text there, as you can see. And then 0.867. So those are the kind of top 5 answers that it was able to find that match this curling gold medal that we asked it to search for. And then the next thing we want to do is say, okay, let's take that information that's just been returned as part of that query that we made to the database. Let's give this now to ChatGPT and tell it, look, here is some new information that we're going to share with you. This is the best quality that we've been able to return from our database system that matches curling gold medal. And then let's ask it the question again. Who won the gold medal in men's curling in the Winter Olympics 2022? And if we do this now, excuse me, it gives us the correct answer. It says the team from Sweden won the gold medal in men's curling in the Winter Olympics 2022. Okay, so can you see this follows that kind of 5-step process that we described in the slides. We've taken advantage of some of the capabilities in terms of dot product, Euclidean distance, so on. We've been able to augment this LLM now with some new information that we've been able to pull out of our database system based upon some criteria that we want to search for, and we've been able to get the correct answer back now. So this is a very straightforward, a fairly substantial example, as you can see, bringing all of those ideas together to show how we can use this. Now, you don't need to understand any of the math behind this, right? The embeddings are done for you automatically. But the thing is, there is a process that you need to go through. And one of the questions previously was asking about errors and phonetics, for example. Great point there. And so there is some additional steps that you would need to do in terms of ensuring the quality of the data that goes in and the kind of answers and the what sort of things that you want to ask of the database system, whether this is the right way to do it, or as Anka was mentioning a little bit earlier on, maybe the full text search could be a better solution because that might help you achieve your business results better in a different way. Great. Okay. Thank you very much for that. So as I said before, there's some great additional examples that we've got. There is a LangChain example here as well that takes that kind of PDF document, chunks it up, stores it in SingleStore, and then asks a question. And again, we use ChatGPT to kind of summarize that article for us. Okay, that's notebook number 4. For this notebook number 4, you'll notice that I am pulling some information from an external source. Okay, it's a website that happens to contain this PDF article that I'm interested in. And so what you need to do is that if you decide, and here it is, okay, here's the kind of URL, okay? So this, if it's something that you want to substitute and try for yourself, be sure to edit the firewall, okay? Here. The firewall is designed to keep the bad guys out, okay? But in order to get access to the outside world from this environment, you need to add the fully qualified domain to the firewall so that it can pull that for you. And I've added this domain leavecom.com where I'm pulling this a PDF file from to the firewall as a rule, so they can do this. Otherwise, it just gives me errors and it won't do it for me. Quickly then, number 6, this is using LangChain again, but using this thing called the SQL Database Toolkit, the agent. This is awesome because what it does, it can let you ask your database questions in plain English. And then you can ask it to show me what is your thinking process. How did you arrive at the answer? And so if you want to make use of this, what I would strongly recommend is that within your, I'll just minimize this just for a moment, okay? Within your environment here, you'll notice that one of the options that you have is this kind of question mark, white question mark on a black background. So if you click on there, you'll get tutorials. One of the options is an interactive tutorial. First option, try with sample data. And if you scroll down, you'll see there is this thing here called TPCH benchmark dataset, okay? So that one, if you select it and you load it, I mean, in my case, it's already loaded. I just had this prepared just in case we had time to cover this. But this is the data set that I'm using for this particular example here. Asking it in English, this question, let me just see if I can show it to you. Write a SingleStore query that shows the highest paying customers per country, include how much they've spent, use the nation name. So basically, I'm just asking it, and what it does, it goes away, looks at the database, determines what the schema is, finds out all the information, and then it shows you its kind of thinking process. And by the end of it, it says here, I know the final answer. Okay, that's the kind of thought process. And then it shows you what the output is to meet that final answer. And one very final point here, just before we stop then and take questions, Q&A, is this number 7 notebook, okay? So visualization is always very useful, I would say. I'm a great fan of visuals. I'm a great fan of Plotly Express in particular, because I like the way that you can control colors and output and charts and things like this. So this example is similar to number 4 in that we take the data set provided by OpenAI, the Winter Olympics. We take the string that we were searching for, the curling gold medal, and we use a couple of steps to scale the data, okay, using Euclidean distance, and we create a plot, a visualization of the data. And this is what that set of embeddings for OpenAI looks like in 2 dimensions, okay? So remember, it's multidimensional, very hard to represent in a graphic, but we can reduce it down to 2 dimensions. So in this particular case, you can see, if you're sharp-eyed, that there are some of these points are kind of red in color. These are very close matches for the curling gold medal string. In other places here, for example, you've got things that are in blue. These are very far apart as far as the query is concerned. So few of these areas, a lot of it is kind of yellow and green there, as you can see, but the reds are much fewer. There's one there, for example. So these would be the equivalent of what we saw when we ran that query, and it was able to retrieve like the top 5 answers, okay? So this would be the equivalent of that. So again, have a look at that in your own time, okay? Great. Well, thank you very much. I think we've done quite well on time. So we've got a little bit of time for some questions there, Q&A. And I think in terms of the slide deck, all I have to show you, basically, I think we've covered all of that. There's a little bit of a summary. I think if you want the slide deck, Shweta will just share that with you a little bit later on. Make sure you've got this, okay? So, but we can open it up to Q&A. Shweta, have you got anything interesting there that people have asked that we can follow up with? I'm very happy to try my best to answer them. As always, they can contact you by email or reach us at team@singlestore.com, and we can follow up as well. But happy to open it up for Q&A now.
Perfect. Yeah, we have a lot of questions that we have left and we haven't answered. It was the time that we were trying to open our hands-on sessions. So I would love to take those right now. There are a lot of questions regarding the embedding and chunkings. There was a lot of questions we addressed on the data size, but there's one question on embedding is done on each data or whether the data object subset to the chunk.
Right. So if I understand correctly, so basically you saw in the number 4 notebook that when we looked at the CSV file that OpenAI had already chunked for us effectively, they had taken the Wikipedia entry for Winter Olympics 2022. So if you look at that page on Wikipedia, you can see it's quite long. I mean, a lot of information there. So essentially, they've taken that text, they've broken it down into rows, of which there are 6,000, was it, and 59, I seem to remember. And so they've divided that article up into smaller parts, and then each of those parts has an embedding associated with it. Now, how to decide what is the level of chunking? That's a difficult decision. I think that requires some trial and error, some thoughts around the design, maybe the particular requirements that you have. And then there are other issues around that as well, in terms of, do you want to have large chunks and perhaps something that is less accurate? Well, it could be actually more accurate, or the accuracy could be the same, but you might be just retrieving such a large volume of data that isn't necessary. So from that visualization, you saw that there's a huge kind of search space that we are looking at. For that particular query that I said, the curling gold medal, only a few of those tiny points were red that actually matched it. Therefore, if you were to store everything in the database as one big article, I'm not sure how efficient that would be. So it's a difficult question to answer. I think this is something that, if people are interested, we'd be happy to work with you through a POC, through some technical evaluation, some consulting, and we can discuss those with you, and we can talk to you about those and work with you to decide, what might be the best approach for you and the particular use case that you have.
Great. I'm sure I'm not forgetting, but I just want to remind all of you guys that we still have the Raffles winner declaration left. So hang on here. We have a few minutes in our hand, and I'm going to do that at the end of our Q&A session. But there are very interesting questions that are coming in, and I want to take some more. Typically, how long the duration example in hours for each step in each step 1:5 ratio or so I think this is regarding the step 1-5 that we have shared in the Python notebook. So they want to know that how long does it take in hours by the anonymous attendee?
Right. Okay. Great question. Again, that depends upon the volume of data. So typically, I think if you're looking at documents that, say we take that Wikipedia example, that's an entry that contains quite a lot of text. But something like that, using OpenAI, I mean, we are using a third-party service to do this for us, agreed. But the thing is, you could potentially use something in-house. So you could store an LLM. There are open source alternatives. You could do this internally, and that process could be done quite fast. I mean, if you're storing tens of gigabytes of data and creating embeddings for those, obviously it's going to take time. It's going to take time to get it into the database system as well, regardless of what type of database technology you use. Very difficult question to answer. Again, depends on data volume, and again, how you divide the text up. How much of it do you actually want to create embeddings for? Embeddings may not make sense for all of it, for example. It again is one of those questions that's very difficult to give a generic answer. Would it take hours? Potentially. Could it take days? Possibly. Again, if you're dealing with, say, hundreds of gigabytes, terabytes of data, you could potentially be thinking about a fairly long time in terms of generating the embeddings. It's probably going to cost you a lot of money as well if you use OpenAI, if it's vast quantities of data. But I would say be picky. Pick up the problem for which this kind of approach is suitable. Don't just go off and create embeddings for everything and then run this kind of query on everything. It's not going to work in all cases. There are situations where this approach is going to be the right one, and there are situations where it's not going to work. So again, choice of problem is an important one, which our great guys like Nidhi and Ankur really can help with.
Great. So I think there's one question for Ankur. Ankur, are you there?
Yep.
Okay, so there's a question on the running the Python notebooks on an on-premise SingleStore setup by the anonymous attendee. Can you take that?
Absolutely. I'm taking a look. Can we run the Python notebooks on-prem? So yes, with SingleStore on cloud, it is an integrated solution where you are running it within the cloud offering, but you can run your own Jupyter notebooks and connect those to SingleStore on-prem as well. So everything that you have seen in the demo works on-prem as well through the Jupyter notebooks that you have.
Yeah.
Okay, so
Absolutely. And I would just add one small point. Sorry to interrupt you, Shweta.
Sure.
There are one or two very specific things that you'll see in the notebooks. I think we use this kind of database -URL for SQL Alchemy. That's peculiar to the cloud environment. The thing is that very easy to just substitute for the on-prem. As Ankur was saying, any of this stuff can run on-prem as well. No problem there. Just to set up a Jupyter environment and you'll be able to load the notebooks in. You may need to make some very small code changes so that it works with the on-prem version. But apart from that, the algorithms that we use, the rest of it should be absolutely fine.
Okay, there are some questions on the by Pramod. I mean, Pramod was facing some query errors, but Pramod, I'm going to share that entire recording as well as Jupyter notebooks right into your inbox, so you can go ahead and try it again. If there are errors coming, you can always contact. I've sent email address at the end of your chat box. So you can see sagarwal@singlestore.com or team@singlestore.com. You can contact us anytime, and we are going to help you resolve those. Another question that I would like to take from Praveen. Praveen, thanks for the question. He says GPT would give generic queries, but how are we ensuring that the generic queries matched with tables and fields specific to our data table, names and fields?
Okay, so this is something, again, you need to have some information about your schema, obviously. In the case that I showed that notebook where we are using the SQL database toolkit from LangChain, for example, it is specifically connected to a particular database. And therefore, when we ask as part of that query, and if you take time to have a look at that kind of long query in English that I kind of highlighted, you see that the names that we are using there are names that are actually used in the schema itself. So basically, yes, we are specifying in kind of plain English, if you like, rather than having to do it in SQL. But the thing is that what the software does, it goes away and does some discovery. Based upon the entries that you put in, it kind of tries to match those to the specific database schema, the actual names, tables. It does some discovery by itself, and then it comes back and gives you an answer. Now, if you don't give it enough information, you may not get the right answer. I mean, don't be disappointed, right? The more information that you can give it, the better the quality of the response you can get, a bit like ChatGPT. So the more information that we can give ChatGPT in terms of what is its role and what we are looking for, the higher the quality of the response that we're going to get back from it. Now, it may not be 100% accurate. That's the nature of hallucinations, as they say. But it's one of those things that, again, this technology may not be ideal for all situations, but in some cases it could be very helpful. Chatbot is one of the cases that I showed that we've used it ourselves. I mean, Squirrel, for example. So great question. Again, very difficult to give a generic answer simply because I think it's a case of if you point it to something that you ask it with appropriate names for columns and fields that it can discover and find, rather than just saying, oh, tell me about this or tell me about that, then obviously it's got far more context and information that it can use to help answer that question.
On spot. Thanks so much, Akmal, for that answer. I want to take this last question. This is both for you, Akmal, and Ankur, and Nidhi also, you can pitch in. He has a Muhammad Istaq, I'm sorry if I have not named you correctly, pronounced you correctly. So he asks, can you tell how we design chatbot where the answer will be given based on the data in CSV only? For example, in e-commerce app, the bot will be answering customer query like how many orders I placed, how much my spending this month. So that's a very interesting idea, actually, because the chatbot application does not limit ourselves to do with what we are trying to tell you right now, but it just opens up the entire can of worms where you can try it in different applications, try it in different forms of implementation.
Okay, I'll just say a couple of words. I appreciate we're almost out of time, but essentially the chatbot can be built in a fairly generic way. Basically, it's just providing the plumbing and the infrastructure. That's what you're essentially doing. And then the calls, the API calls to whatever LLM you are using. As far as the content is concerned, it doesn't matter. If it's a CSV, for example, that's fine. I mean, you can load that in. if you can create the embeddings for the data that you want to search, you could provide like an input box, for example, that allows the user to type in whatever query they want based upon the particular data set. And you could do some discovery, for example. So just a couple of days back, as you know, within SingleStore, Jason Thorsness did a demo where he actually used GPT-4 to build a visual interface for him for a particular data set. And then he could actually query that based upon that data. So it's not a difficult problem. The bot itself can be very generic. Whatever data source you have, you can consume that, you can read it in whatever format you want, but have that process of creating the embeddings and then having that visual front end, if you like, if that's the way you want to do it, to be able to ask those questions in a way. But you need some context. Again, obviously understand what the data is that you're getting. If you ask it a question it doesn't know anything about, you'll get, it's garbage in, garbage out kind of thing.
So
do
I
you have
just want
anything to add on that? Yeah.
Yeah, just
sorry.
one thing I want to add on the CSV part as well, because if you have enterprise systems where the data is coming in CSV format, with SingleStore, you have native pipelines to kind of ingest that CSV data into SingleStore, and the rest remains the same, what Akmal just explained in this whole webinar. Rest of the process remains the same. The data comes in through CSV, gets automatically loaded into SingleStore, and all the other activities remain as they were discussed in the webinar.
Great. I think people are still sending us questions, but there is an interesting question, which is going to be the last one because we ran out of time. We still have to announce the winner for the AirPod. Yeah. So
is it me? Have I won?
I wish.
No, I'm not eligible.
You're not eligible.
No.
So the last question is the embedding process the same for OpenAI's GPT or Meta's Llama 2? That is both generate the same numeric value for the same object / word?
No, because these transformers are different. And so I think if you try it, you'll find they produce different values. That's my understanding. Yeah. I
think that's a great idea to do the next one with the Llama 2, so they can see the difference.
Oh, absolutely. Yeah, we ought to do something focused around just purely open source. I mean, like I said right at the beginning of the presentation, the reason OpenAI is good is because it's kind of like the Rolls Royce. It is the best quality, the Premier League, and therefore in terms of what, and the cost keeps going down all the time. They do charge some money, but it just gets less and less and less over time. But right. Yeah, open source. Okay, so
right. So we just ran out of time. We in fact 3 minutes over. I don't want to leave this without announcing our winner for today. So Gaurav Mehta, and Gaurav Mehta is the winner with email ID Gaurav_Mehta_1@optum.com. So Gaurav, many congratulations. If you're here, you can write something on the chat. Okay, Gaurav has written us. Thank you so much. I'm sure you're excited. So are we. Akmal is disappointed he didn't get the one, but you did a great job, Akmal, doing this session. It was lengthy, but it was so insightful. Thank you very much. Gaurav, you can see the AirPod delivered to you in a few days. You can contact me directly at sagarwal@singlestore.com or team@singlestore.com. Guys, and if you want to have further queries, you want to try out SingleStore, you want to try SingleStore on AWS, don't forget, we're always here. I have my email addresses at the bottom of the chat. The PDF and PDF of the PPT is going to share it with you, which will have our contact details and all the instructions with Python notebooks in your email in the next 1 hour. So do look up for it. Thank you so much for joining. The next session we are doing is on August 25th and August 31st. Feel free to go to singlestore.com/events, where we have all the listed webinars at different time zones. The August 25th and 31st are APAC specials. So we're going to do some hands-on workshops again, only for the APAC audiences. So do have a look at those as well. Thank you so much for joining today. Have a great evening. Take care. Bye-bye.